So I want to welcome you all to this, the 7th IPNSIG Academy webinar. And I just want to remind you that if you're interested in IPNSIG Academy, at the top of our homepage, there's a link to IPNSIG Academy events. And if you click that link, you'll see a table of all past and planned IPNSIG Academy events, and with links to videos and presentations as they become available. Just a reminder that this event is being recorded, and we ask that you please post your questions in the Q&A box. There's a link marked Q&A at the bottom of the page, and they'll be answered at the end of David's presentation. There'll be a Q&A session. And so I'd like to introduce our presenter, David Gomez Otero. He has over 20 years experience in telecommunications and space systems, and has contributed to the design, development, and test of commercial and institutional space missions, such as Gaia, Galileo, Meteosat, Quantum, and EDRS. He's a telecommunications systems engineer in the European Space Agency, and David supports several industrial technology and product development related efforts related to telecommunications satellite systems and services. And he is currently the technical lead for the European Space Agency's Moonlight initiative preparatory phase, an ambitious project to bring telecommunications and navigation capabilities to the moon, which will support future lunar settlements and perhaps become a stepping stone towards human deep space exploration. So I think we're in for a really engaging and interesting presentation. Please take it away, David.
Hi, thanks, Mike, for the introduction. Can you hear me well?
Yes.
Okay, so hello, everyone. Good morning, good afternoon, good night, depending where you're sitting on the globe. This is UK, so it's 9 p.m. for me. It's a real pleasure to be here today, contributing to the IPNSIG Academy. So thanks to the organizers for having me. It's nice to be here today talking about what ESA has in mind for connectivity on the moon. So over the next 30-40 minutes, I will summarize what we are up to in Moonlight, and then try to dwell a little bit about the things we are encountering when thinking about networking on lunar, cislunar space. So perhaps let's start from the start. Why are we doing that? So why do we want to put networking on the moon, connectivity on the moon? So over the last years, there has been a greater interest about lunar exploration, seen as a way to learn, maybe to live off planet. And that has kind of like give us a perfect excuse to talk about networking. I mean, networking in interplanetary networking is not something new. The IPNSIG has been created for a long time ago, but without a user, it's very difficult to justify something like that. So luckily for us, we see that the number of missions on the moon is growing rocket high, and more and more missions going to the moon. On the European side, ESA has also great ambitions that we are proposing for the next ministerial cycle, bringing different assets on the moon and being a reliable partner for exploration with contributions to the Artemis and Gateway programs, and looking forward to have a first European on the moon before 2030. Before we jump into the technical stuff, I always like to have a view on this. I think it's very relevant. This is a snapshot from the moon market analysis released a few months ago by NSR. I mean, they have been releasing this report since a few years already, and it's remarkable to see the number of missions planned to the moon. So we have today over 250 missions planned for the next 10 years, with an aggregate value of $100 billion US, which is seen the seed of this lunar economy. So what we see now is that, as opposite as 50 years ago, it's not about institution, public agencies fueling alone. but there is a great interest from commercial players. So we see non-space organizations like mining companies, mobility companies, we see suppliers, logistics. So I think the whole commercial market is realizing this is like in the next continent. It's like discovering a new territory and you know, bringing their products there, and they see there is a big piece of the cake. They always want to have them. Communication and navigation is one of the fundamental pillars, is a basic infrastructure we have seen on Earth. I mean, nowadays, if there is no good connection, we all get annoyed. So I think it's clear this is one of the enablers for this future lunar economy. And this brings me to the vision behind Moonlight, which is to bring communication and navigation services supporting the current and the next generation of institutional commercial explorers. And I think an important thing to mark and emphasize here is the word services. So Moonlight is not it's not conceived as an infrastructure designed and owned by the agency, by ESA in this case, to support, I don't know, institutional missions. This is designed to be a future service, a commercial service. So in a nutshell, basically the same that we see on Earth, where we see communications as a commodity, as something we use, and we don't really think about that as something we need to build on ourselves. I mean, we buy a service and we buy from a commercial carrier, and we have that. So we have also these already existing on Earth with SATCOM commercial operators. So what we would like to see is SATCOM commercial operators on Earth to take this role of lunar SATCOM providers and engage in this together with the agency. But of course, it's not easy. So we think that at the very beginning, at least, there is a need for some institutional support to help bring this new infrastructure, which is not cheap, and also enable this start service rolling the dice, let's say. So Moonlight and LunaNet. I think I would like to set the scene by having a few words here. I'm sure many people are asking perhaps already this in their minds. So we had last month a presentation from Dave Israel from NASA talking about LunaNet, and it's great that it was done in this order. So it made my life much easier to talk about Moonlight. So if we remember, LunaNet is defined as a framework for interoperability in the cislunar region. Indeed, LunaNet, we are working together with NASA, developing this set of specification standards, which is a great pleasure, of course. And this should be the foundation stone for the standards to be used for lunar missions. Moonlight is ESA's proposal for the deployment of a set of services. So Moonlight at some point is a bit like a project. So there will be a service associated, and there will be an infrastructure delivering these services. Of course, Moonlight will be compatible with LunaNet, so it will live within the umbrella that we are defining within LunaNet. So I hope this sets a bit the scene. What is the roadmap for implementing Moonlight? So the roadmap for Moonlight is two stages, let's say. Step one is the Lunar Pathfinder Partnership, which is a joint venture between Surrey Satellite Technologies, SSTL, in the UK, and the European Space Agency, where the European Space Agency is procuring services from SSTL, and SSTL is in charge of designing, delivering, and deploying a lunar relay on the cislunar region that will provide low data rate communication services, but also allow to mitigate some technology elements for the future navigation service. So again, this is also a joint venture. This is a partnership between a commercial provider and institutional provider, which is quite unique. And actually, if you go into the details, there is also a cooperation with NASA on that. So it's a very, very interesting venture. This is intended for launch by 2025. And then after that, we will follow with a Moonlight constellation that will provide high data rate communication and navigation services. By the way, that's what we call LCNS, because it will pop up later. So Lunar Communication and Navigation Services. We are on the design and developing, and then the initial services should be delivered by 2027, around that date. a bit more details about LCNS. So we've been working on this for quite some time now. We did some internal feasibility analysis and small industrial studies that set the scene to conclude that this was an interesting thing to look into detail. And therefore, by April 2021, we released this definition phase study, phase AB1, with 2 parallel competing consortia that you can see here on the left. One is led by a company called Telespazio in Italy, and the other is led by SSTL Lunar in the UK. And you can see the logos of the different consortia members. As you can see, industrial teams include satellite operators, which could be potential service providers, and large system integrators for space and ground, plus technology providers, so very, very big teams. We are about to finish this phase as we speak, which is will allow us to move into the next stage. And if I just briefly talk about what we are doing on these studies. So there are 2 parallel streams. There is a technical stream, which is basically the typical thing that you do on a definition study. You look into mission requirements, then you try to define service and system concepts, define a system architecture, and then do a little bit of system design and segmentation of the different elements. But being this a public-private partnership, we need to look at the other side. So we need to define what is the service delivery models, the business development aspects, market streams, partnership models, what should be the roles between the agency and the commercial providers, ownerships, SLAs, these kind of things that are necessary to set up this new service. And in December 2022, we are planning to release the invitation to tender for the full implementation, of course, subject to the ministerial approval. We have our, so maybe not everybody knows, I mean, ESA works in ministerial cycles of 3 years. And in each ministerial cycle, the projects and the funding are approved for the next 3 years. So we are having this by the end of November 2022. And then the full implementation for Moonlight will be discussed. So what are we doing now? What are the next steps? So we are now working full steam in the implementation, in the preparation for the full implementation that will be approved, like, as I mentioned, in the Ministerial Council. We released recently a request for information for this phase B2 CD, trying to see interest from industry across ESA member states. The RFI is already closed. However, as part of the RFI, we included some draft service ConOps and service requirements, which are available. You can follow the link on this QR code if you have interest to see what are the requirement needs that we are specifying. Again, maybe I just use a minute to say that the procurement approach is service-oriented, not system-oriented. So we are not buying a system, we are buying services that, of course, require a system. So that means we work with service requirements that, of course, will be translated into a system requirement, but this system requirement is industry's job. So this is important. This is a partnership. So it needs to work for both the service provider, the consortia, the industrial consortia, and the agency. So we need to take we need to take work together and find whatever suits best to all of us. The invitation to tender is planned for December 2022, if the program is approved, of course, hopefully. And then again, also we are planning a study for a lunar downstream application that is intended for the end of the year. And here we want to see what are these applications, downstream applications that could be enabled for such an infrastructure like telepresence on the moon, gaming. We hope we can find very interesting commercial use cases here. What is the service offer that we foresee? So we see 3 main pillars. So communications, navigation, and what we call other services. So the communications, we are structuring them in 2 main blocks, data relay capabilities and messaging capabilities. The data relay is basically transmission of data from A to B. So here we see some subcategorization or maybe some labeling or classification of these data relay services. It can be real-time or non-real-time. So real-time would be minimum storing, minimum latency. So basically end-to-end free space transmission plus some minimum internal system latency. Non-real-time would be store and forward services that could have latencies from minutes to few hours, depending on the priority of the service and the user need, of course. High-low data rates. Here we are following the implementation recommendations from SFCG, Space Frequency Coordination Group. I think it's 2R4 recommendation that defines a different frequency bandwidths, and high data rate will probably follow within the K-band, with S-band following using for the low data rate. High-low priority to help flexibilize a little bit the scheduling of the services, and then critical and nominal services depending on the operational requirements. So critical services will be those that are critical for the mission success, or could derive, non-provision of this service could derive on loss of mission, for example. And the messaging service is something a hybrid internal-external service. So messaging should be enabling users short messaging, for example, kind of like Internet of Things like service. It could also allow, for example, send short messages to provide status, or even could be the channel for allowing users requesting services, a kind of random access channel. But it can also be used to orchestrate the network, or manage the network. So communication between the different nodes, even for different providers, enabling, for example, a common channelization or signaling for roaming and internet working. Navigation also classified into big blocks, real-time and non-real-time. Real-time, it's the one-way ranging, which is basically single source one-way ranging. Position and velocity, which is multiple sources of one-way rangings to provide real-time PVT. Time dissemination, and then two-way ranging, with which resembles the more traditional deep space ranging that we have on a coherent two-way channel. Non-real-time services, we can see something like post-processing PVT, which is using different passes over time to provide a much better accuracy than the real-time ones. And on the other column, these are services which are built from combined capabilities, combining communication and navigation capabilities to create a different product. For example, search and rescue is something that could be quite interesting. And when we talk about search and rescue, of course, everybody thinks about astronauts, and that's not wrong. So a sort of a COSPAS-SARSAT extension for the moon. But there are other alternatives. For example, a search and rescue could be seen like an emergency call from a robotic asset, informing on a malfunction and requesting intervention from the mission operator, for example. We see also a possibility for alert and newsfeed service that might be using, for example, the messaging capability or some of the capabilities that the navigation signal is able to provide. Third-party payloads embarked on the LCNS infrastructure itself, hosted payloads, and over-the-top services that could provide additional services using the infrastructure. That's the same that happens here on Earth when we see connectivity and we see all the service providers streaming, video streaming services and so on. Okay, so I want to try to explain a little bit what is the infrastructure. Bear with me a little bit. So I can't really show and go much into the detail of the physical system, because we have still two competing consortia that are under contract providing a sizing of LCNS, and we are about to jump into a competitive phase for the next full implementation. So of course we cannot disclose the exact implementation of the system or very detailed diagrams. Nonetheless, I think that provides a nice view of what we are up to. So you can see here the segmentation of the system into 4 different segments. The Earth ground segment, which is composed by all the infrastructure needed on Earth to provide the service. Basically, we need at least 3 grounds emplacement 120 degrees apart to provide a 24/7 coverage on the Earth side. There will be interfaces to the users for the delivery or acceptance of the service request, and also delivery of the data. And then, of course, interfaces with other providers, allowing users to maybe interoperate with other different providers. On the lunar area, we will have the LCNS space segment, which will composed by a small constellation of satellites. Here we can see maybe 3 to 4 nodes in some sort of a fancy elliptical orbit that will maximize the service coverage on the South Pole, as you will see in a slide or two, providing the comms and the nav services. We also have the surface segment, which maybe it will be coming in the future. But the idea is that there could be some communication infrastructure on the surface, like a hub, acting as a local hotspot, and then collecting in the data the surface network and communicating to the space segment. And then the user segment, of course, this is sometimes forgotten, but it's a very essential part, because the system is nothing without users. So we need to carefully think about the user terminals that will work with the system, and also that they are okay and acceptable for the user, so that they don't add additional constraints that could maybe make the difficult more complicated. There is there might be some connection with the gateway, so we will see what is the interaction. But of course, the gateway is another node on the cislunar space, so it makes sense that there is some potential interaction. And then here, this other little cloud here is very important. This is other service providers that will for sure be on the moon. I mean, there will be different providers from different agencies, but also maybe completely independent commercial providers at some point. And it's very important that we have a connectivity across them, because we should be able to interoperate with them. Just briefly talking about the service requirements. So this is a bit tough work to put it in a couple of slides. So if you are curious to have a little bit more insight on the details, just follow the link that I shared about the draft ESA service requirements document, and then you'll see more. The thing is that there are a lot of different combination of cases, and then it's not possible to just have a single number defining that. And actually the details is always, the devil's in the details, and then exactly how things are defined is important when you're understanding the context of a number. So some details I prefer to omit, and if you have curiosity, you are welcome to look at that. So LCNS should be able to serve commercial and institutional missions, deploying after 2026, 2027. We want to work on the assumption to work on an open interface. So we don't want a closed system. Also, this links well with interoperability. We would like to see something that works in an open way, and then the user can have flexibility to decide what is the sort of user terminal, maybe buy it as a custom off-the-shelf device, or maybe do it itself, because the interface is open and is available. The system needs to be scalable so it can grow over time, fulfilling the growth of the lunar economy. And of course, we are looking we are well aligned with regulations. So for example, as I mentioned before, we are using, we plan to use the Space Frequency Coordination Group recommendations. We will of course be well aware of LunaNet specifications, the ICSIS standards for Gateway and Artemis, ITU recommendations, RTU regulations, and so forth. The system should support, or the service should support, the different mission phases. And then talking about the service volume, this is also a tricky one. So for a start, the main target service volume is around the South Pole. So this, let's say, minus 70 degrees, minus 90. And then perhaps a service volume of a couple of 100 kilometers, which is what it will cover landing, descent, ascent operations, and surface operations, and low lunar orbiters as well. However, there will be some service available and at a wider volume. So we want to see best effort coverage up to 7,000 kilometers, which is the orbit of the Gateway. And of course, global surface coverage, again, in best effort. This means the performance will not be that good, perhaps, or maybe the repetitivity, so the time coverage will not be that good, but still a service can be provided. In terms of capacity and communications, also this is a tricky one. High data rate services in K-band, up to 200 megabit per second user, TVC. I mean, it's tricky because, of course, it depends on the user terminal. So we are thinking about different classes of terminals, small, bigger, according to the capacity. Not all the users will want to have 200 Mbps, and not all the users will be ready to fly such a big terminal. So maybe there will be terminals sustaining a few megabits per second, or maybe a few tens of megabits per second. And low data rate, similarly, offered in S-band, again, up to a capability of perhaps 1 megabit per second. But S-band is a little bit different. So low data rate is not just about low data rate. It's about a different way of using that. So S-band is a frequency, a lower frequency, therefore free space losses are lower, and therefore you can afford a different way of operating. For example, you can have an omni-coverage antenna, so having a 360-degree coverage, and therefore being able to send messages to the system without knowing where the satellites are, or without the system knowing where the user is. So this could be, for example, a good way to implement a random access channel for accessing the network and getting also network discovery information, so you can know where you should put your requests, things like that. Security functions. So of course, the system needs to implement and respect whatever security levels are required by the user. So we will have a transparent security interface, so the user can bring their own key and get it through the whole system. And then over time, maybe then the system can implement additional functions. The services, at the beginning, it will be very difficult to have continuous coverage 24/7 on the moon. So probably working in slotted real-time services, maybe 10, 12, 15, 18 hours a day, growing depending on as the service grows and maybe more infrastructure is deployed. The navigation, I mean, it's not the focus of today, but maybe just say that there's compatibility with the LCNS. Deploying a sub-microsecond timing dissemination, which could be also interesting for the networking and synchronization of assets, local times. Position accuracies of 100 meters for orbiters down to 10 meters on the surface, and the post-processing could even go one order of magnitude lower, and velocity accuracies on the 1 meter per second. Okay, so after this concludes the first overview of Moonlight, and now maybe talking a little bit about networking. So, I mean, there's a lot of work behind and going on, so we are not discovering anything new here. So we saw, I think, last presentation or a couple of presentations ago, there was a presentation on the solar system internet working architecture on the CCSDS. We know the colleagues from the IOAG communication working group have been working for a few years on developing a comms architecture for the moon. We have LunaNet, we have IXIS, we have a lot of standards, we have a lot of guidance, and we have DTN. There's a lot of stuff. However, when we go to the point where we say, okay, let's do a project, let's get something working, it's difficult. I mean, where do we start, and what do we start with? So what should we implement at first? What is it needed? How can we grow? Because I think it's obvious that we cannot have a full-fledged network like on Earth on day zero. Indeed, I think that calls for a gradual deployment. So if we see what has happened on Earth, I think that the lunar internet will follow also a similar approach. So let's take the example of mobile communication. So in the 80s, 1G, let's say, as an analog voice-only system was deployed. Terminals were unique, big, bulky, of course, but also non-interoperable. So you had your terminal, it worked with your service provider, and that was it. It was only 10 years later with 2G, when there was a little bit of mobility and roaming, and the users were able to use their services in another different country. But of course, it was very rudimentary, it was expensive to use, it didn't work very well. So it took 20 years to the community, mobile communities, including technology providers, user terminals, and service providers, to understand that that there was a need to define from the foundations something that was designed to be interoperable, not patch something. So that's when the 3GPP partnership project was created. And since then, we have very affordable and very optimum mobility. So you have your terminal, your phone, I just go overseas, I go to the US, and then I have data, I have a seamless experience as a user, the same interface for invoices and payments, so it's perfect. So yes, the lunar internet will grow gradually, but of course we need to be able to leverage all this know-how of decades of work, not only mobile networks but also SATCOM. So on Earth, the predominant commercial standard for telecommunications is DVB, which works very, very well. So I think we need to challenge ourselves and see. Of course, we need to think out of the box, but the main issue is I mean, we are ourselves the issue. If I put now my hat on the agencies, is the users are not used to that. So this is a pill that will need to be swallowed very, very slowly. So today, most of the science missions, communications is an essential part of the mission. So the communication capability is specified within the system requirements. It goes to bespoke equipment. Its mission has its own infrastructure, and of course it makes sense. If you think about a huge telescope like James Webb, that has a huge cost. I mean, nobody wants to hear about network. They just want to know that whenever they need the data will be transferred and there will be no risk, nothing. So everything will work well. So if you start talking about networks to the users, it's difficult. It's not that easy. The future, of course, comes as a third-party service, as a commodity, like we see with normal networks today, where nobody has even considered the possibility to build their own mobile network. They just buy an existing terminal and that's it. Models as pay-as-you-go, monthly fees, so the user can use data as they need and as much as they need and pay proportionally. And of course, very importantly, a standardized universal user terminal or terminals, family of terminals that it will work exactly. For example, what happens with SATCOM receivers are standardized to use DVB and they work, or 3GPP mobile networks the same. So this is where we'll have to go, but it will take time. So in Moonlight, we are thinking about how to see the network. I mean, it's not easy. So we are thinking in deploying the system in stages. So we see for Moonlight 2 stages, the initial operational capability and then a full operational capability. And we want to use that to give a little bit more flexibility. For example, IOC will start with some basic relay connectivity. So the typical ABCBA scheme, and maybe pre-scheduled contact. So it's not going to be very flexible, but it will work. So point-to-point connectivity, maybe some basic routing, maybe at a frame layer, maybe, I don't know, maybe a little bit more, but it will work. It might be something that the user is a bit comfortable to use because it is under control. It's not a network. In reality, it's not a network. It's a point-to-point connection. We would like, and the idea is to make it DTN compatible. So if a user is implementing a DTN bundle protocol stack, that should be working with this. I mean, maybe the system is not very intelligent, but it should work. And then we could use that to do some network trials. So we could start thinking about, because I mean, hopefully we are talking about regenerative payloads. So it means that maybe we can have some software flexibility, some SDR on board, and maybe we can upgrade a part of the service to do trials and see how it would work, and then slowly convince the user and prove that the system works, and bring them to the full network approach on this FOC, which we foresee maybe for the 2030s, something like that. So FOC, we would like to see a full network with routing capabilities, perhaps an end-to-end native DTN based on bundle protocol 7, or if there's something newer. This will allow higher flexibility. It will allow fancy things like user-initiated services. By user-initiated services, I know it's always a bit confusing term. It means that the lunar asset can initiate a communication session asynchronously without being tasked by the ground segment. So this allows more autonomous missions, so that let's say the rover is traversing in an autonomous way, and it makes there is something, an anomaly, or maybe there is an opportunistic science where it sees some feature which is interesting, and it will just drop a message before even the planned session, just to say, I found this, what should I do? And then the user can, reconfigure the planning and do that, knowing that the data is network-wise, so it should work well. and messaging service that will allow all these things as well. And then in the future, maybe we talk about on-demand services with dynamic resource allocation like we have on mobile networks, automatic management. So if a user pushes a request, the system is automatically finding and allocating resources without a manned intervention, so it can be on the spot, very flexible. And then, of course, allowing roaming support. So in a transparent way, the user uses available resources on the moon without having to care, is this belonging to this organization, is this belonging to the other? Because the service providers on the background will have their SLAs, service level agreements, and they will make whatever they need to make this happen. So what are the challenges ahead? I mean, there's a lot of things that we need to work, and the more we work on the topic, the more we realize we need to work more. So, for example, there is a lot of resources already available. I was just saying before. I mean, the DTN implementation is there, bundle protocol is CCSDS. So there is a lot of things available. But for example, there are elements we need to work. For example, the user hailing. So proximity one, which is standardized today in UHF, allows a mechanism for a user hailing. We need to work to have this on the moon. So we need to maybe upgrade proximity one in S-band or in K-band, or maybe we need to think other ways for allowing the user to hail in both directions, from the lunar asset to the relay, but also from the relay to the lunar asset. We need to think about signaling and control planes always on. Why I say that? Because of course, for example, K-band communications have antennas which are very directive. So the user needs to know where the relay is, and the relay needs to know where the user is. Otherwise, there is no connection. So a signaling plane that is always connected is not obvious, like on Earth. I mean, you don't have an Ethernet cable that you plug into the network and then you are connected. So maybe an S-band signaling channel could be interesting, that could allow continuous communication between the asset and the network. So you can track the user, you can page it if you need it, you know where it is, and so on. We need to, user paging, tracking, and monitoring. This is something that you need to have a continuous channeling for doing that. How to manage all the dynamic resources, how to allocate resources and take the resources back when they are no longer needed to optimize the spectrum available. This is something we need to work. Channelization policies, how much bandwidth can the user take, make sure that there's a fairness in distributing this. Roaming support across other service providers, how to automatically seamless allow this in an automatic way. This is something which is quite challenging. And of course, network governance. We will have a network, we will need to maintain different nodes from different providers like the internet. And this we need to develop this network governance. And mobility management, I think it's a bit linked to the before, but that's something we see on 3GPP networks. So how to know the user, how to know where to find it, and how to have a database with all this information. So we have a lot of challenges ahead, but it is very exciting. So I think that on the next years, we will hopefully work on that in Moonlight, and we will be able to contribute on this vision for a solar system internet, maybe only the moon for now, but everything's possible. Okay, I think that brings me to the end of my presentation. Here you can see the link to two links. On the left, there is the link for the Moonlight website. There are a few information articles you can have a look if you are curious. And again, on the right, you can see the link to this RFI, request for information with draft service requirements. And in the middle, the Moonlight email. If you want to ask anything, I mean, you're welcome to contact through that. So I give the mic back to you, Mike. Thank you.
Sure. Thanks. And we do have a number of questions for you. First, from Alberto Montilla, who's one of our board members. Do you see a point in which Moonlight and LunaNet becomes, quote, the same thing, end quote, from technical specification perspective?
Okay, I think maybe this is seeing LunaNet as a system, but LunaNet is a framework. So I don't want to speak on behalf of NASA, but I mean, it's public information that NASA is launching a RFP for a communication relay service. As expected, I mean, all main players with missions on the moon will want to have sponsored providers. So LunaNet and Moonlight, the same thing. Well, LunaNet is the framework. So let's say Moonlight is an implementation of LunaNet, so to say. So the idea would be that the lunar providers will adhere to the LunaNet in the same way that mobile manufacturers adhere to the 3GPP standard release, because otherwise they will not sell a phone because it will not work across the whole ecosystem. I don't know if that answered the question.
Well, Alberto is not shy. I'm sure he'll speak up if it doesn't.
Okay.
And then from Scott Burley, for the LCNS comms service, is there any anticipation of a need for multicast? If so, is that documented in the ITTs?
No, we are not requesting a specific multicast service, but it depends. Okay, it's a very good question. So it depends on the beam configuration, which is something we are not specifying in the service. Maybe I would be cheeky and bounce the question back. Is what do you think are the use case needs for a multicast service? Because we are open all ears. So actually one of the struggles that we have been having over these years, and I will now cry out and share it with everybody who is listening, is to go to the user and really understand what the user wants. So what do you want? How can I help you? What can I do for you when sizing what is Moonlight? And it's not easy to really get some clear statements. So if you have any ideas on the reasoning for a multicast system or a solution or service, I mean, please shout out. You can just drop an email if you want, or maybe follow up with a question, because I mean, if it's interesting and there are applications, I mean, we can think about that, of course.
Okay. So the next question is from Jorge Omodio. What plans do you have or envision to have wired or wireless networking on the moon? And he's talking about Wi-Fi when he says wireless. And I can understand the question because a lot of the literature just kind of assumes that Wi-Fi will be the de facto LAN, local area network on the lunar surface.
Yeah, for the time being, Moonlight is not focusing very much on the surface networks, but of course we reckon that we call it MSS, Moon Surface segment, is going to be at some point there. The IOAG Lunar Architecture Report foresees some standards for the lunar surface. Wi-Fi is for sure inside. 3GPP, and actually, it's a very nice question. It brings me the opportunity to talk about that. So 3GPP is with 5G, we have seen in release 17 the extension for NTN, non-terrestrial networks, which has opened the door to integrate natively 5G functions in the satellite. This has some complexities, but it has some advantages. And then I think we could at some point open the elephant on the room and say, should we consider the NTN implementation release 17 ahead, perhaps even for the relay to surface communication? And I'm gonna win a lot of enemies by saying that, but I think we should be open to look into and explore different things. So for the surface, the current idea is already considering not only Wi-Fi, but also 3GPP release 14 onwards, so LTE onwards. And I'm sure all of you know about this experiment that will fly on one of the CLIPS missions with a Nokia base station, trying to do some tests on 4G.
Okay, so the next question is from Juan Florire. He says, you mentioned possible modifications to PROX-1. Why not considering USLP?
Yes, of course. USLP is, yes, you're fully right. USLP is, of course, considered within the stack of protocols. It's both mentioned in the IOAG Lunar Report and in LunaNet. And if I remember well, USLP also seems to inherit the hailing capabilities of proximity. So actually, it's a very good idea that maybe USLP could be a solution. Yes. But Prox1 is also an interesting standard, so it's worth to consider. The only thing is that it will require work because Prox1 now is defined for UHF, and it's thought for a Mars environment with tens of users. But maybe on the Moon, if we end up having hundreds of users, we will run out of addresses on Prox1. So maybe you're right. Yeah, maybe USLP is better. So this is an open question as today.
And another one from Juan. What options are available for EU institutions that missed the recently closed RFI?
Good point. No problem. So this RFI was not initiating, and I will clarify this. This RFI was a request for information. We wanted to know a little bit what is the footprint of the interest across European member states. I shall say that, I mean, ESA projects are only industries or institutions within the countries that compose ESA are allowed to apply directly to an invitation to tender. So the RFI was not exclusive. So it doesn't mean that people that miss this RFI are now going to be out at all. So after the CMIN, when the ITT is out, it's an open call for everybody within the ESA member states to participate.
Okay, and then I have some more generic questions for you. So you started, engaging, business entities as part of your initiative, and what have you experienced, and what do you foresee to be the biggest challenges in trying to establish, partnerships between institutions and businesses?
Yeah, that's a good question. It's not easy. The thing is that I think most of the private institutions recognize there is a growing opportunity on the Moon. So there is a good opportunity on the Moon. It's a new market to explore. But as of today, there's no one on the Moon. So that makes the business case highly speculative. So it is based on a lot of assumptions, a lot of if, that, if, what. And this means private entities, which are, of course, very thoughtful of their own fundings, which we fully understand, of course. There is a struggle of, okay, I think this is a nice opportunity, but it's very risky. So I think the key here is the support from public institutions. So I think the role here is for ESA as a public institution to support this, fueling this first generation of service provision by contributing to the development and deployment of the infrastructure itself. And of course, I think perhaps as a customer buying services for ESA missions and maybe partner missions from other agencies. So I think this is a well-known issue, and this is where an agency can play a role and make a difference.
Yeah, that's very insightful. Thank you. Now let's flip the record over and play the other side. And well, those of you that are old enough to understand that metaphor, what do you see as the biggest opportunities for partnerships between business entities and institutions?
Okay, I'm not sure if I'm going to be able to answer well the question, but I will try, and then you let me know. I think it's a first mover advantage. So if we are opening a new era of exploration of planet, and if this is really going to grow to a sustainable economy, there will be very good opportunities for many different players across a really wide range of businesses on Earth. And we see that when we realize, looking on the news over the last years, how apparent institutions or companies that had nothing to do with space suddenly were mentioned in one of these lunar missions. On our side, I talk about the commercial service providers for communications. Well, navigation is so far not a commercial service, but it can be. For communications, if I just focus on communication, so we see the example of SATCOM on Earth. So there is a very healthy ecosystem of communication service providers in the different orbits, LEO, MEO, GEO, and it works well. So I think the opportunity is to open a new market, is to change the paradigm. So far, exploration was living out of institution communications based on the, for example, the ESA infrastructure, ESTRAC, or NASA's DSN. And we are opening the possibility for this to become a business. So the companies that are happy to jump in this game and help us define that, they are potentially winning, being first or firsts in a new market. And this is the moon, but maybe later we will see Mars, and maybe we see something more. So it's a new window opportunity, I think.
Yes, thank you. So we do have a new question. This is from Keith Scott, who's an IPNSIG board member and also a member of CCSCS. How do you see interoperability between Moonlight and other, for example, NASA implementations of LunaNet? How would you see joint operation, for example, scheduling, working?
It's a very good question. Actually, this is a topic we are working with NASA as we speak. So we have some working groups defined where we are thinking what are these scenarios for joint CONOP? So how perhaps an ESA mission will use maybe a NASA-sponsored service provider, how a NASA mission will use an ESA-sponsored service provider, and what are the use cases. So I think there is the sizing of the need for communications on the moon, if the lunar roadmap implements in full, will be very, very big. So it's going to be hard for a single service provider to be able to serve everything. And at the same time, it is too much of a responsibility. I mean, on Earth, we have multiple assets, so we have redundancy. So there are scenarios where, for example, you have multiple coverage at the same time of different relays from ESA and from NASA, in order to give hot redundancy on a very critical mission operation. So you don't have a single point failure for that operation. There are other scenarios where maybe the user has such a huge need of data that you need two links at the same time, maybe. Or maybe other cases where there are coverage gaps because the relay is not available, or there is too much request at the same time. So we are working on all these scenarios and how this scheduling function would work, because there is a need to think about how is this going to be coordinated through the agencies, through the service providers. This is something I cannot answer with a diagram on the table, because this is what we are working to as we speak. But we clearly understand this is something we need to define, of course.
Okay, thanks very much. And then another question from an anonymous attendee. No, it's not inflammatory. It's not. How you define the time on the moon? Will the definition of the moon time related to be related to the terrestrial time? If yes, how will you handle the leap second?
Okay, this is something which this is not my area of expertise. We are working on that. What I can say is that how the time is defined is something we are working as we speak. There are some we have some technology definition activities in ESA that are looking into all these details of exactly how to do time transfer. You are right. The idea today is that the constellation is controlled from Earth. So that means there needs to be a synchronization from the different satellites. And of course, because of the time, the latency between the Earth and the relays, there is this, you need to have a mechanism. So that there are technologies for time transfer, and we are studying how to implement that, because of course, the local time of the relay, it directly impacts the accuracy of the navigation solution. So you need to have a very good, stable, and synchronized time source. So the exact details on how this is implemented, I cannot answer, but I can tell you this is something we are working, certainly.
Okay. And another question from Massimo Capozzi. The key pillar of having an open interface for proximity links is interesting. Which will be the standardization body to manage this coordination effort?
Yeah, this is a very, very good question. Thank you. It is difficult to answer, because we need to see if we reach a point where we can impose something. If you look at the LunaNet, document, there is a large collection of proximity configurations. So there are different frequencies, there are different modulations, different codings, different frame sizes, and then the protocol stack also will be different. So it's going to be difficult to have that. And I'm not sure if we will succeed in the short term to have a single interface. Like, for example, the 3GPP is a good example. There is a single radio interface. So it's the same technology everywhere, which makes it very easy. For now, it is very difficult, because we need to go back and again think about the user. The user is used to a certain, very not very flexible, let's say, modulation scheme and protocol stack. And if we say drop everything, you need to use this, which is a complete new piece of technology, it's going to be complicated. So I think the starting point will be a set of recommendations. The service provider, of course, will have the last word on what do you want to use, and gradually things should be converging into perhaps a set of solutions, or even a single air interface, hopefully. But I don't think we have the ability to impose anything to anyone today. So actually it's the other way around. The service provider will need to be very flexible in order to make sure that you are not missing any customer, any user. I don't know if this answers, Massimo.
Well, it sounds like it could be close to an imponderable question. We are 2 minutes away from our endpoint, so I think we need to kind of wrap the Q&A session and just go into some final closing thoughts. So if you don't find that objectionable, could you advance to those slides?
Sure.
Great. So just a reminder that you can find the that table of Academy events with links to videos and presentations at the link on the upper left here. If you have questions, shoot an email to secretariat@ipnsig.org. And if you could go to the next slide. This is the events next month, just around the corner. Ed Brain is going to talk about IETF standardization efforts. He's very active in the IETF working group. Followed right after the New Year holiday by Keith Scott talking about the CCSDS standardization efforts. So if we could go to the next slide. I think there's one more slide. Yeah, so we're just inviting you to become a member. There's actually a couple of ways to do that. We did have some issues with the automated membership management application when we were kind of in a limbo state between being a chapter and being a special interest group. That's been resolved. And we're going to update the instructions on the website. You can simply go to the ISOC, the Internet Society, but isoc.org will get you there, website, and click the become a member link, enter the information, then that will take you to a page where you can select the chapters or SIGs that you want to join, and simply select the interplanetary chapter. Or you can send an email to membership@ipnsig.org, and Scott Burley or myself will manually enter you into the membership roles. So that I think is it. And would really like to thank our speaker. It was just really, just a reminder, thank you. Thank you. You will be given a short survey, and we really rely upon this information to make our IPNSIG Academy presentations as meaningful to you as possible. And it helps us track things like what regions are people attending from. But I really want to thank David for a really engaging presentation. I learned a heck of a lot, and I'm sure all of you did. We had a lot of interesting and thoughtful questions, and we will be putting up the video and the presentation as soon as they're available. Actually, we'll probably put the presentation up today on ipnsig.org. And so if there's no closing comments by David, we'll declare the mass ended and go in peace.
Thank you very much, everyone, for listening. It was a pleasure, and see you on the moon.
That's right. Vince Cerf always says, see you on the net. David says, see you on the moon.
Both
right.
work. Okay, good night and good day, everyone.
Okay, thanks very much. Have a good day. And thanks again, David.
Thank you. Bye-bye.